Hi everybody. Today what I want to do is go over how we take and turn a VT graph into an AT graph or into a DT graph. Now I do go over this in my PowerPoint presentation, but this will serve so that you can kind of see live and in person how it's done. You are going to need a calculator, so make sure you do have one. It'll just make things a little easier if you work it along with me. So let's start with going from VT to AT, or acceleration time graph. Doesn't matter what order we do it in, but the AT graph is a little easier, so that's why I want to do this one first. So what we see here is I've got a little sample VT graph, and I first want to talk about what's going on in this graph. So if you notice, we start out with a negative velocity of about negative 12 meters per second, and we stay at that constant negative velocity for about 4 seconds. We're then going to increase our velocity to a positive 18 meters per second over about 5 seconds. Then we will travel at another constant velocity, okay, for about 4 seconds. And then finally we will slow down to 0 for the last 5 seconds of travel. So how do we take and then interpret this into an AT graph? Well, the key is to remember what an acceleration is on a VT graph. And what the acceleration is the slope. The slope of the line at any point equals our acceleration. So if I take a look at this first region from 0 to 4 seconds, I could see that there my slope would be 0 because it's a flat line. So I can come over here onto my graph and say for my first 4 seconds, my acceleration is 0. Now we look at our second segment of the graph. Here we said we are going to have a positive acceleration. Well, what is going to be the value of that acceleration? To do that, we have to calculate the slope. So we know that slope is delta y over delta x. So my x is going to increase from 4 to 9. So that means my change in x is 5 seconds. My change in y, we go from negative 12 to positive 18. So I can do that calculation as 18 minus negative 12. Always do our second value first. That gives me positive 30 meters per second over 5 seconds. So my acceleration for this region is positive 6 meters per second squared. So I'm going to come up to positive 6, and I'm going to be at positive 6 until I reach 9 seconds. And I'm going to put in my connector. And so far my graph looks like this. My third segment, again, we have a constant velocity. Since we have a constant velocity, again, my acceleration will be 0. Now, that runs from 9 seconds to 13 seconds. 10, 11, 12, 13 seconds. Okay. Now my final segment of the graph, this section right here, I'm going to be decreasing my speed. So as we said before, we're going to have a negative acceleration. So for that segment, again, I'm going to do delta y over delta x. We go from 13 seconds to 18 seconds. That is again a change of 5 seconds. And my velocity is going to change from positive 18 down to 0. So 0 minus 18 gives me negative 18 divided by 5, which is negative 3.6 meters per second squared. So I'm going to come down to about 3.5. And that's going to run to the edge of the graph, put in my connecting line, and there we have it. The last thing for me to do is to make sure that I have a label on my graph with a unit, and this is what my graph would look like. Okay. Why don't you pause this for now and then review, make sure you get the concepts, come back when you're ready, and I'm going to be discussing the DT graph. Okay, so now we're ready to talk about our DT graph. With our AT graph, we were interested in the slope. With our DT graph, we're interested in the area. Okay, so the area under our velocity time graph gives us our displacement. Now, you'll notice that I don't have any values here. That's because I don't know what they're going to be yet. I have to wait and do my area calculations first, then I can put them into this graph. So let's take a look at our first segment again. We said we're going to be looking for the area under the graph. Now, under is a relative term. It's basically between the bounding line and the horizontal axis. So for me here, that is a rectangle. So the area for section 1 is just going to be the length times the height. So that is negative 12 times 4 seconds, meters per second, 4 seconds. That gives me negative 48 meters. Okay. Area 2. Now, for this graph, I'm going to have 5 areas as opposed to my last that I had 4 slopes. So now I want to do this small triangle here. For that section, again, it's a triangle, so my area is 1/2 the length, which is 2 seconds, times the height, which was, again, negative 12 meters per second. So 1/2 times 2 seconds is 1 second, so that gives me negative 12 meters. Okay. My next segment runs from here to there. So my origin line over to the top of this triangle. So that's area 3. That is 1, 2, 3 seconds. So again, we have a triangle. 3 seconds is my base. And as we said, we're going up to 18, okay, meters per second. That gives me 27 meters, and that is positive. I'm going to repeat now for this rectangle. That's from 9 to 13 seconds, so that's 4 seconds. Again, it's a rectangle. So 4 seconds times 18 meters per second. That's, again, positive. And I do put this in my calculator just to double check. 4 times 18, 72. And now I'm going to do my last section, which is again a triangle. 1/2, that's 5 seconds. 14, 15, 16, 17, 18, 5 seconds. And again, we started at 18. So that gives us positive 45 meters. Okay. So now I want to put in values on my axis. So I can see that I am going to have a large displacement here. So I want to go by a large value. So I'm going to make each line be 10. So that's going to be negative 20, negative 40, negative 60, 80, negative 100, 20, 40, 60, 80, 100. Okay, and this is my displacement in meters. Okay, so we start at the origin, and for our first 4 seconds, we go down to 48 meters. So 48 meters is approximately 50. Now, we have to remember, here we're traveling at constant speed, constant velocity, so that is going to be a nice, straight as I can get it, line. In region 2, we were accelerating. Okay, we had a positive acceleration, so that means we are going to be getting faster, getting closer to 0 each time. Now, for those 2 seconds, I traveled an additional negative 12 meters. So, to 6 seconds, negative 12, that brings me to 60. And as we said, this was a positive acceleration, so I'm going to be starting out at a high speed, going down to 0, so I want to put a curve in line. Okay, coming to 0. I'm now going to increase my speed, or increase my displacement by positive 27 meters. That's over 3 seconds. 1, 2, 3 seconds. Again, we're accelerating, so this line is going to be curved. And I'm going to be going up 27 meters, which is approximately 30. 10, 20, 30. So we're going to be a little less than 30. And I'm going to make this a curve. Better curve. Oops. There. Okay. My next is a positive 72 meters. That is also at a constant velocity. So that's going to be a straight line. So we're going to go up 70 over 4 seconds. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7. Straight line there. And then I'm also going to increase for my last portion by 45 meters. But again, I'm going to be slowing down, so I should have a curved line again. Okay, so I'm going to be starting fast and getting slow. So I'm going to go up 45 over the course of 5 seconds. 2, 3, 4, 5. 1, 2, 3, 4 and a half. Like so. Okay, if you have any questions, please send me an email.